I must say that you are not the first one who tells me that it's the first time crossing the equator for multiple world. And he's not the only one in this room as well. So, questions? Questions? Yes, Andrew.
So one of the things that's different this time around maybe is you alluded to it in your talk that the innovations might not be available to physically buy anymore, only to rent. How does that, I mean, so for example, we have the CPU with the HBM on it from AMD. And then you mentioned all the special accelerators from the hyperscalers were all doing stuff like that. How does that potentially change that theory of jump to the next thing when the next thing is not something you can physically buy anymore?
I'm actually not sure how that's going to affect things yet. It could have quite a big effect, couldn't it? And it could really be a sort of moat effect that at some point Google could decide we're going to keep this thing just to ourselves and not let anyone have any access whatsoever. We'll just use it for our own internal services because we think that's going to give us an amazing advantage over everyone else at the moment. But I don't know if this is true for everyone, but they're sort of renting out time on these things to customers and using it themselves. But that might not always be the case. Perhaps while we can still rent time on these things, that potential partitioning isn't really being felt to its fullest extent. But if those companies at some point decide we're going to keep this to ourselves now, it might have a bigger effect on the market. So we've not seen perhaps what could happen with that, but we might at some point. Yeah, I do worry about that a little bit.
Dan Stanzioni from Texas Advanced Computing Center.
Thanks. That was quite the introduction for asking a question. Thanks, Simon. Great talk. I'm just curious, particularly around the simulator work, which I thought was cool. I've always thought a lot of our GPU CPU comparisons are really unfair because typically the GPU is a much bigger die running at a much higher power that we're comparing to, and I've never seen a good comparison of what sort of an architectural advantage of GPU. Is really the streaming memory versus cache-based memory, right? Or is it just that it's a bigger piece of hardware? Have you tried any of those sorts of comparisons, right? I mean, if we had a 1,000-watt CPU with a similar number of functional units to a GPU, what would it still? Where would the GPU still have an advantage, and how big would the advantage be?
Yeah, that's a really good question. Who's it said that when someone says that, it means they don't know the answer? It's actually a question we're about to start some work on with one of our partners. Right now, we need to do some work. The simulation engine, it can actually run multiple core simulations in parallel, but it doesn't scale very well. So we're about to fix that to the point where we should be able to model hundreds of cores in parallel, running one model per real hardware core. So that's how we're going to do it. We've got some of that working already. But that's exactly what we want to try. What if we put 1,000 CPU cores on a chip? And people have actually done this sort of thing for real, but we just don't have the results to be able to answer that sort of question. How similar does it end up being to a GPU? And at the end of the day, it's how much HBM have you got? How many execution units have you got in a certain amount of area using a certain amount of power? If you have a bunch of very wide CPU cores with vectors in, that looks pretty like a GPU, right? There's no kind of magic in any of this. So those are the sorts of questions that we're very interested in, and we'll be doing more on that over the next year or two.
Larry.
I do want to just follow up on that because I think what you said is very true. To me, one of the big issues, and I'll admit that I do somewhat abstract some of these challenges, but Little's law is the enemy here. And that means that in order to exploit the bandwidth from something like HBM at a given latency, and those latencies look like they're getting worse, not better, you need concurrency. GPUs generate concurrency like crazy. CPUs are much more challenged, and adding cores the right way to deal with it? I actually like the SVE, SME paths, but then you have these challenges of contiguity. How do you deal with sparsity? How do you generate enough concurrency in order to actually be able to leverage those memory systems? Yeah. So, I mean, that still feels like the fundamental problem that has not been solved in the CPU realm. Even for those instances that we are seeing today, I think ARM has a lot of promise in a lot of the stuff they're working on, but then you have to find people to actually implement those architectures. Yeah. And that is a big challenge.
I put this back up just because I think, I don't think this completely solves it, but the indicators are, if you have 1,000 instructions in flight from one CPU, and this is 200 loads and stores from one CPU, and these aren't huge CPUs either, so you could have there's 12 in my laptop size chip, but if you had 100 of those, right, how similar does that then end up looking to a GPU? So I think it's a great question to really look into a bit more.
Balance.
So you mentioned that you see one of the big challenges with AI is that the algorithms change so fast, right? So in that context, do you see any space for some reconfigurable type of architectures, and not FPGAs, but something more capable or like coarse grain type of thing?
Yeah, so the question was about FPGAs and things FPGA-like. Yeah, that is one of the places where there's some interesting developments, and there's some sort of startups promising quite interesting things, and that sort of reconfigurable, it's a bit too crude a term, reconfigurable type architecture. They're always a little bit on the back foot because the overhead of making things reconfigurable is quite high. So I've not, other than some very specific things, I've not seen anything that needs to be a bit more general purpose come out that's really competitive from that slightly more reconfigurable architecture. But it might do. So there are a few things to keep your eye on in that space to see if they really can do something interesting here. But so far, nothing really compelling has come out with that approach yet.
So please join me thanking Simon for the fantastic talk.
Thank you.